Today we are going to start a new topic, classification of acids. First is classification based on depending upon elements present. Firstly, we will classify the acids on the basis of elements they have or elements present in them. First is in this category, depending upon elements present in this category, we have first term is oxoacids. Acids that contain both hydrogen and oxygen are called oxoacids. Acid that would contain both hydrogen and oxygen are called oxoacids. For example, sulfuric acid H2SO4. It has both hydrogen. Hydrogen is present. Hydrogen atoms are present, and oxygen is present. And in nitric acid, hydrogen is present, oxygen is present. In phosphoric acid, hydrogen is present, oxygen is present, and that's what oxoacids. All these are examples of oxoacids. Acids that contain both hydrogen and oxygen are called oxoacids. All these are examples of oxoacids because they all contain both hydrogen and oxygen. Next is hydroxide. It's also in the category depending upon elements present. It is first term and this is second term, hydroacids, acids that contain hydrogen and other non-metallic elements. This would contain hydrogen but not oxygen, except oxygen. Oxygen would not be here, but other non-metallic elements could be. For example, HCl, acids that contain hydrogen. Hydrogen is here. In hydrocyanic acid, hydrogen is here. And other non-metallic elements. Other non-metallic elements, it's chlorine is here. Chlorine is halogen. And CN is here. It is also a non-metallic element. And these are the examples of these. Both are the examples of hydroacid because they contain hydrogen and other non-metallic elements. Moving to next category, acids may be classified as follows also. Organic and inorganic acids. All sour things that we use in our daily food contain acids. The foods which taste sour, they contain acids. These are called organic acids, which we come across in our daily food or daily life. Some of the common acids that we use in laboratory are called hydrochloric acid, sulfuric acid, and nitric acid. Some of the common acids which are used in laboratory, these are also called mineral acids. They are HCl, H2SO4, and HNO3. HCl along with the mineral or inorganic acid, it is also present in in the gastric use in our stomach. In the stomach, it is present in the gastric use. It is also gastric use. Concentrated and dilute acids. An acid solution may be concentrated or dilute depending upon the amount of acid present in the solution. An acid solution may be concentrated or dilute depending upon the amount of acid present. Concentrated acids must have higher amount of acid than water, but dilute acids would have less amount of acids than water. An acid is generally used as solution in water. When solution contains a large amount of acid, it is said to be concentrated, whereas dilute solution contains smaller amount of acid. Thus, concentrated and dilute solutions of an acid differ from each other only in the proportions of the acid. Proportions means amount, concentration of the acid. If the concentration of acid is high, then water in it, because solution is made in water. Acidic solution is made in water. If the concentration, if the amount of acid is much higher than the water's amount, then it is concentrated acid. But dilute acid, there is large amount of water than acid. That means proportions are different. If the less proportion is less, then it is dilute. Next category is strong and weak acids. The strength of an acid is determined by the amount of hydrogen ions that the acid provides when dissolved in water. When we dissolve the acid in water, it would dissociate. The it would dissociate, mean the acid would break down into ions, H positive, H positive ions or hydronium ions. This is called dissociation when acid breaks down in water. When we will dissolve the acid in water, it would get dissociated, it would get broken down. Some of the acids when dissolved in water get completely dissociated. They just get completely dissociated to provide hydrogen ions. These acids are called strong acids. These which completely dissociate to provide H positive ions. These are called strong acids. For example, hydrochloric acid HCl. When it will dissolve in water, how would it get dissociated? It would get dissociated into H positive plus Cl negative. It had only one hydrogen and it got completely dissociated in water. It dissociated to H positive ion and Cl negative ion. In sulfuric acid, H2SO4 would dissociate completely. It would get completely dissociate to give two hydrogen ions. In nitric acid, it would completely dissociate to give H positive and NO3 negative ions. On the other hand, there are some acids which when dissolved in water are only incompletely dissociated. Means they do not give that all their hydrogen ions in their dissociation. They do not completely break down. They just break down to some extent. Some of the examples are carbonic acid, H2CO3, means all the hydrogen ions would not release from it, would not get dissociated. Only to some extent there must be dissociation, and same in the case of acetic acid, CH3COOH. The next topic is dilution of the acid. Dilution of a concentrated acid by adding water is a highly exothermic process. Dilution of an acid. What does it mean? That concentrated acids are the acids which have higher proportion of acid in them, high content of acid, but water is less. So when used in schools or some other institutions, concentrated acids are also there, but some of the experiments are performed generally with dilute acids. So to make to make a acid dilute, dilution of a concentrated acid by adding water. When we will add water to the concentrated acid, if acid would be in a container and we will add water to it, it must be a highly exothermic process. Exothermic process is the process in which high amount of heat, a lot of heat would evolve. A lot of heat would evolve. Heat energy is so large that it may turn water into steam. Imagine that when you throw something in the water, water splashes out. But in this case, in that bucket, if you would take the example of bucket, if you have placed the bucket and in the bucket there is concentrated acid, any of the concentrated acid, and when you run water in it and when you just put large amount of water in it, all that water may turn into steam, or it may turn water into steam because large amount of heat energy is produced. Because it's a highly exothermic process, large amount of heat would evolve. That heat may turn water into steam instantly, resulting in splashing of acid. That acid will splash or it may cause burns or harm to you. So a concentrated acid should never be diluted by adding water to the acid. When we want to dilute acid, we have to reduce the concentration of acid in it. Then you should never dilute by adding water to acid, but we must add acid gradually to the water. When we will take the container or any of the beaker, we will take water in it and then slowly we'll add acid to it gradually, so that in doing so the small amount of heat produced is safely absorbed by large amount of water. Next is basicity of an acid. Basicity of an acid is defined as number of replaceable hydrogen atoms present in a molecule of the acid. It is the number of replaceable hydrogen atoms, number of replace hydrogen atoms which could be replaced in a molecule of the acid. The acid which has one replaceable hydrogen atom in its molecule is called monobasic acid, which has only one hydrogen atom present in it. For example, HCl, HNO3, they have only one hydrogen acid atom present. So they are called monobasic acids, and our concept is basicity. Basicity is number of replaceable hydrogen. How many of the hydrogen atoms we can replace from them, and its basicity is 1. The acids containing 2 or 3 replaceable hydrogen atoms are called tribasic acid, tribasic acid if it would have 2 replaceable hydrogen atoms, and if it would have 3 replaceable hydrogen atoms, we may call it tribasic acid. Let me give you some examples. If H2SO4 is dibasic because it has 2 replaceable hydrogen atoms and its basicity must be 2. And in H3PO4, it has 3 replaceable hydrogen atoms present, then its basicity is 3. Let's just see 1, 2, 3 examples in the next slide. Yes, acid is HCl and its 1 replaceable hydrogen is present. Our definition of basicity of the acid, basicity of an acid is the number of replaceable hydrogen atoms present in a molecule of the acid. It is a molecule. It is one molecule of the acid. HCl is an acid. It is a molecule of the acid. When atoms combine, they form molecules. It is a molecule of an acid. How many of the replaceable hydrogen atoms are present in it? Only one replaceable hydrogen atom is present. Then its basicity is 1. Next is HNO3. Nitric acid. In nitric acid, there is also only one replaceable hydrogen is present. Then its basicity is 1. Then next is H2SO4. Sulfuric acid. 2 replaceable hydrogen atoms are present, and definition of basicity of an acid is the number of replaceable hydrogen atoms present in a molecule of the acid. Then its basicity is 2 because 2 of the hydrogen atoms could be replaced. Next, about the preparation of the acids, we will do it in the next video.